Suppose you adjust your garden hose nozzle for a fast stream of water. You point the nozzle vertically upward at the height of 1.8 meters above the ground. When you quickly turn off the nozzle, you hear the water striking the ground next to you for another 2.5 seconds. What is the water speed as it leaves the nozzle?
Okay. So, what are we looking for here specifically?
We're looking for the initial velocity of the water leaving the nozzle of the hose.
Right, and what are we given?
We are given the height of where the hose is above the ground, where the
Right.
water will leave from.
Let's call
We're
that
also,
why
oh,
not?
sorry.
Keep going.
Then we hear the water striking the ground next to us for another 2.5 seconds. So I think that's like the initial contact of the water after it's gone up and down and hitting the ground, and also for how long it continues to fall there, showing like how much water was let out of the hose.
Right, agreed. So, we're looking for the initial velocity we're given. We know that acceleration is negative 9.8 meters per second squared, right? Because it always is in the air.
Oh, so yes, we have the force of gravity as a number we can work with.
Perfect. Why not? I'm calling it why not because it's the initial height is 1.8 meters. Y final is 0 meters, and our time is 2.5 seconds. Now, can you think of which kinematic equation is going to help us solve for this? I'll write them all down. V final equals V initial plus AT. Making this one delta Y since it's vertical. It's the same as delta X equals V naught T plus 1/2 AT squared. V final squared equals V initial squared plus 2A delta Y. And delta Y equals V final plus V initial over 2 times time.
Wouldn't V final equals V initial plus AT be the right way to go?
It's pretty good. Do you want to try it out?
Sure.
Okay. So we have V final equals V initial plus AT. How should I start filling this in?
So start with 0,
0 for what?
V final.
Is V final actually 0? V final is going to be the velocity as it hits the ground.
Oh no, okay.
So we don't actually know V final. However, you're thinking of V final at the very top, which is a good thought. But we don't know the amount of time it takes to get to the top. So we don't actually know V final at the bottom here. Let's try a different one maybe.
So all these contain V final and V initial.
Not all of them. There's one that doesn't contain V final.
Oh, is that number 2?
Number 2, exactly. So we have delta Y, and I'm going to rewrite delta Y as Y final minus Y initial, because that's what delta Y means, equals V naught T plus 1/2 AT squared. And yeah, let's begin to fill this in. We have that Y final is 0, Y initial is 1.8. We're solving for V initial. We know the time is 2.5. We have negative 9.8, and then 2.5 squared. That was a real close cutoff there. Let's begin to simplify this. What's 0 minus 1.8?
Negative 1.8.
Nice. And then we have 2.5 V naught plus, and then I'm going to actually do minus here. What is 1/2 times 9.8 times 2.5 squared? It's definitely a calculator question.
So I got rounded negative 30.63.
Perfect. Now, how should we do the algebra from here? What's my next step?
From here, could we divide each side by 2.5?
We could, but we'd have to divide 1.8, 30.63, and this by 2.5. So I think if first we add 30.63 to both sides, it's going to simplify things a lot more. Well, actually, let's do your way, just to make sure that people know that they can do it. Because it is an option. It's technically correct.
60% of the time, it works every time.
That doesn't make sense.
So we're dividing both sides by 2.5.
Okay.
So on the left side, we have negative 1.8 divided by 2.5, and we get negative 0.72 equals 2.5 V naught divided by 2.5 is just V naught, and then 30.63 divided by 2.5, we'd have minus 12.25.
We could add 12.25 to the other side.
Perfect.
And then we would get our answer that way.
Yes. Let me know what you get for the final answer.
I got 11.53.
Yeah, nice. Same here. Great stuff. Yeah, that's it for this one.
So I'm just curious, did we solve the problem, or did we solve a part of the problem that we can plug in to solve another part of it?
We actually solved the problem. What is the water speed as it leaves the nozzle?
Oh, so we had enough to go off of for that then.
Yeah. So this problem is level 2 difficulty, and we're used to doing a lot of level 3 difficulty problems.
Oh, I see. So we took the bull by the horns then.
Exactly.
Okay.
Couldn't have said it better myself. Good stuff.